Yeah, so I'll cover all of mobile mapping, but part of that'll be on the MX50. So this first slide we got an MX9 on, but yeah. So I'll get started. Like Troy said, my name's Skyler Neumeyer. I've been with Trimble about I think about 6 years now, mostly working on mobile mapping. I did spend some time on the machine control side on the construction team. And then I ended up coming back to mobile mapping when the MX50 was being worked on. I do a lot of the testing on the hardware before systems are released, and a lot of working with customers and advising. And I always explain a lot of my job is hearing from customers and hearing complaints and suggestions, and then getting to complain back to the engineers and kind of carry those through. So if there's any thoughts, questions, concerns, I'm always happy to take those. And luckily, I've got John in the room who represents the reality capture team for the Americas. So I got somebody there in person. If there's anybody with angry complaints, he can take those. And then if there's good suggestions, you guys can email them to me after. We can go on to the next slide.
Oh, it's not going to let me. Hold on. Sorry.
You're good.
There you go.
Yeah. So just a quick intro on what's mobile mapping. So for our context of mobile mapping, it's going to be the mobile LiDAR and camera systems. So you'll see I have a cheesy next slide about, it's any collection of data from a mobile system. So you could call sticking a rover on top of your car and dropping topo points could technically be mobile mapping. For our context, it's usually kind of a sensor fusion between LiDAR sensors, IMUs, GNSS, imagery, that kind of whole package. So if you want to go on the next slide, there's kind of the cheesy dictionary definition, and then if you go to the next slide, we'll take a look at what does it actually mean. So for our kind of range of mobile mapping systems, it's typically survey oriented. So there are mobile mapping systems that are just a camera. So everybody's pretty familiar with Google Street View. Those are technically mobile mapping systems. Ours are kind of focused towards the surveying, engineering market, DOTs, the federal government, things like that. So they're all going to contain high accuracy GNSS and IMUs, high accuracy LiDAR. It's going to be able to kind of augment or replace more traditional survey methods for a lot of use cases. The place where it typically fits in for most of you or most of our customers is when your projects are too big to do any other way. So today we've seen, Pete mentioned the X7, the X9. I think most people in the room are usually pretty familiar with static scanning. The traditional, that was kind of the early adoption. But there's those projects that you just can't static scan. We've done thousands of miles of scans that would have just not been possible even over, many weeks, multiple survey crews, and we can collect that amount of data in, a few hours. The other kind of use case where I see, besides just huge projects that are too big to do any other way, the kind of secondary time where we see mobile mapping really come into play is just increasing safety. We have some DOTs that require use of mobile mapping on certain highway projects, even if they could be done other ways, because they don't want, boots on the asphalt, guys playing Frogger out there. And I know that was my life for a while, was running out into the center of the road to shoot in, a center line or a road stripe. And so for some of the DOTs specifically, that's kind of one of their main use cases. Most of our collections are on open roads. Sometimes we'll have highway patrol or blocker vehicles just to clean up the data, but we can capture at regular traffic speeds and keep everybody out of harm's way. There are some initiatives that require entire surveys done without any boots on the asphalt, and that's where we come in. The last two bullet points are just a couple kind of key things with mobile mapping. Is we make a lot of data. So I'll talk some of the details of the MX9 on that, but internally at Trimble, a lot of times if we're testing, cloud stuff or data storage, we'll test a lot with mobile mapping because, we are kind of typically known to have the biggest data sets, the most data, the most images to deal with. I've got personally about 40 terabytes of scan and imagery just sitting around my desk and in my PC. And then the last bullet point is just simultaneously collecting the images, the point cloud, positional data, and then we can also connect other sensors to the system. So we have some kind of sensors doing GPR measurements of the road for underground utilities. We have some customers connecting really high-res cameras to capture house numbers and pole tags on power poles. So the system itself is kind of the core, but you can always add additional accessories onto that and simultaneously collect everything using the positional data from the MX series. If you want to go to the next slide, we'll take a quick look at, there's other mobile mapping systems, but, we're going to kind of cover a few of the reasons, I'm biased, but reasons why to go with Trimble for mobile mapping. If you go to the next slide, it'll have the portfolio. So to give a little background, these systems are kind of the culmination of working on mobile systems for about 15 years. Trimble started in mobile mapping from the acquisition of a Canadian company called Geo3D. And at that time, these systems were not very fun to use, not very fun to train on. We would basically receive a vehicle and outfit the vehicle with server racks, and an operator would take up the whole back of a van. The systems are permanently mounted. People would come in to have training for multiple weeks on how to operate the system. And now after many years of mobile mapping being a very specialized thing, it's become much simpler, much easier to get started in. So nowadays I always say we can have you operate in the system in an hour or two, and then usually the office side processing is a little longer. The training for that is maybe a day or a day and a half to get everybody up and running, but 2 full days to get started versus 3 to 4 weeks for early systems is really, we've gone leaps and bounds over the last 5 to 7 years. So to kind of summarize the portfolio, we've got the MX7 on the left. That is an image only system. So very similar to what you would see in Google Street View, similar qualities of images. The camera, the Ladybug 5 Plus used on these systems is actually what Google used to use at up to a couple of years ago for all their stuff. So what you're familiar with, you would kind of expect the same thing. But the difference is you're up to date, so your images are current and they're positionally accurate. So, Google Street View might be accurate each image to however many meters. The MX7 is accurate to about 5 centimeters positionally, so you can make measurements from the images and still have kind of GIS grade accuracy. So it is image only, so there's a lot of upsides to moving into LiDAR, but we still have lots of customers doing asset management, GIS collection for cities, things like that, using the image only system. If you want to go back one, the MX50 is the mid-range system. That's one of the ones we're going to kind of chat the most about today because it's the newest. And then the MX9 is the premium high-end. That's the one that you're building bridges with and doing 1,000-mile collections with. Okay, we can go to the next one. And then I just had a couple key updates on the MX9. I know we're going to talk a little bit more about the MX50, and we'll still chat on that. The MX9 had a mid-cycle update most recently, so that's why I had this slide in, was just showing some of the newest changes on the MX9, just because it had the more recent changes. So the key updates in the bottom left, you see the colorization of the point cloud. We actually made some improvements on both the MX9 and MX50 to improve the accuracy of colorization. So I'm not sure about everybody in the room there, but I never really cared for colorization. I didn't use it for any actual work. I always felt that it was more for pretty pictures and presentations and things like that. But we made some improvements, and the colorization positional accuracy is typically sub 1 centimeter. So, that's colorization of, say, a road stripe matching up to the intensity contrast of a road stripe. So now it can be used for things like, road stripe extraction, looking at the colors on signs for attributing, things like that. So colorization, it's still a little bit of a fluff thing, but some of those improvements made it more usable than it's been in the past. The top right is an example of the UI for running the system. I mentioned a little bit ago that it's a lot simpler to run than it used to be. There's a record button in the bottom right. You basically drive around, your background map's on the left side. You hit record when you want to start recording. That'll switch over to a stop sign when you want to stop. So when we were developing the system, the engineering team the kind of idea we always bounce back and forth, and it was somewhat hyperbolic, but it was that we want to be able to throw the system on an Uber or a taxi and just give the tablet to somebody and they should be able to record. That simple. And then the bottom right, so the density discussion is a little different than static scanning. So the MX9 is 3.6 million points per second. The MX50 is 1 million points per second. But the big kind of difference versus static scanning is it's a very consistent density. It does change with speed, so the speed that the vehicle is traveling. But if you travel through a corridor at roughly, say 45 miles an hour the entire way, you're going to have a consistent point spread across that entire corridor. And one of the benefits of that over static scanning versus where you get kind of real high densities right near your scans, and then further away you get lower, and then you get to the next scan and it goes high again. It's a lot of the feature extraction tools generally perform a little better with the consistent density. I know when I take data to the feature extraction team that works on developing these tools, they're always much happier to work with the nice consistent data sets, even if our consistent density won't be as high as say an X12, 5 feet away from it. It's just gonna, be the same as, say 30 feet away from an X12, but for the entire run. We've started kind of hitting a plateau of densities. So for a long time, there was a bit of an arms race on each manufacturer had come out with higher and higher densities. At this point, 3.6 million points per second is kind of more than we need for any of our analysis. There's a couple of niche use cases where we turn it all the way up, but most of the time we actually run the system turned down a little bit because, like I said, the data is just giant. The MX9, if you run it all maxed out, like theoretical maxes, creates almost a terabyte of data per hour, which isn't necessary for most things. Cool. Let's go on to the next slide. So now you have, 5 billion points of a corridor. What do we do with that? So this kind of section is a little bit more focused on, the collection's done, you've got some data, or what kind of deliverables can we create from that data? So there's a couple videos in this section that I'll kind of talk over. Normally I show this all like live in the software, but that I'm very slow at that, so that would be a whole hour presentation. But if we go to the next slide and we can start the video, and then just hit full screen, and I'll just kind of chat over it once it opens up. Cool. If you want to hit full screen, I don't know, maybe it's big enough on the slides, but what I'm showing off here is kind of something that Ben brought up briefly during his presentation, is some of the new pavement condition reporting that we can do with the data. So that's been a big new tool for us because it basically opens up a whole new type of project that we can do. So what we're doing is we're basically looking at deviations in the road surface from the LiDAR data and identifying things like potholes, rutting, heaving, corrugations, basically all these components of the ASTM PCI standard. And then we use the downward facing camera on the MX9. So if you have the MX9, you can also do crack detection, and we'll see some of the cracks here in the video. The MX50 will do all the other defect types, just not crack detection because it doesn't have the pavement camera. But we've got a lot of our customers that are running this that, maybe they have a system for these big serving and engineering corridor projects, but they want to keep that system busy, when they don't have these huge projects. And municipalities, DOTs, hire out a lot of work in just condition analysis. And so This tool still a little new. We're still kind of fleshing some of the bugs out of it, but we've got a lot of people pretty excited about this. And hopefully the video is showing up okay for everybody in the room. But it was just kind of showing the red and blue deviation report and then how that matches up to the different defect types. Cool, and then we'll just go in. There's just another one right after this. And one of the nice things about Trimble mobile mapping that kind of sets us apart from some of the other systems is it's just TBC. It's just a module in TBC. You do all your processing in there. Historically, 6 years ago, 7 years ago, we did have a separate software for it. A lot of our competitors still have their mobile mapping software, and then they have their survey software. And you can always get things translated back and forth. You can do all your processing, export out in LAS, and then get it into your other software. But we bring the raw data right into TBC, do all the processing, do all the run matching here. And then instead of an export and an import to start doing some of your CAD work or your extraction, it's just click over to a different tab in the list of modules up at the top. So right here, I'm just showing some curb and gutter extraction in TBC. I'm sure a lot of you guys have used it on static scanning or seen demos of it. This is another one where I think mobile makes the tool run a little better. You have these nice long linear projects that have a lot of curb and gutter you need to extract. So just showing that process here. At the beginning, I also showed turning everything off, but except for the ground. So I know Ben kind of keyed in on the classification training that's in the new TBC version. But the other thing I've been promoting a lot is the new deep learning based classification model, the new base model. So everybody's probably seen the traditional classification that we've had for probably close to 10 years now. The new one is basically better in every metric, and it has more classes. So now those vehicles driving through, impatient drivers passing the mobile system while we're collecting can all be automatically removed. I get just the ground, and then I start extracting from there. Then the last couple videos are just touching on some other softwares that we work with. We have dedicated exports to TMX, which is this software. It's great for publishing, sharing the data. Not everybody wants a terabyte of LiDAR data on their PC. So for, say, a DOT that we work with, the survey group might have TBC, might do all the feature extraction, but then they want to share this data with a GIS group or an environmental division that just need to make some measurements. So in this example, they're just kind of driving down the road, extracting tree locations. So say this is like a city planning department. They don't need to know all the secret sauce of what's going on, all the LiDAR. They can just have basically a Google Street View image and go through and automatically click on these trees. We're extracting things like drip diameter and height. And, that's all possible because of the point cloud in the background, but we can kind of simplify this process for certain users. We'll let this play out for a second. This can also be set up to, TMX Publisher can be sold through all the Trimble dealers. We basically white label it, and you can set this up on a browser so that, when you're sharing the data, they're, like I said, not downloading, a terabyte of data. They can just view. You can kind of constrain what they're looking at, and just let, in this case now it's showing some power pole extraction. So that division, you could just give a certain subset of the data. It's just the power poles, just the point cloud, share that with them. They don't have to download anything special. They just open it up in their web browser, make some of their measurements, and go on. So that's been a huge kind of component of mobile mapping in the last few years is sharing the data easier. These huge data sets are, I will say, inconvenient. We still have a lot of people shipping hard drives around. I'm sure some of you do that still. And then the last video, I'll just kind of preface it. It shows Topodot, which is another software we have a direct export with. We work real closely with them. A lot of their work is similar to some of the feature extraction you can do in TBC. It's similar to some of the feature extraction you can do in TMX. All three softwares have their own kind of pros and cons. Topodot's still really popular with a lot of our DOT customers, doing full survey extraction of corridors. So if you're doing big projects, speeds of the most importance, we still love Topodot. You can see how fast their lane line extraction tool is here. So in this example, I just go through and do some quick lane line extraction. It's still my my favorite tool in their software. And one of the other benefits of going into Topodot is it's built on top of MicroStation. So if any of if your design teams are already running in MicroStation, that's one big pro for them, is being able to stay in one ecosystem. And then here, I'll just extract the the center split of the double yellows. And then basically at this stage is just showing, how much distance was automatically extracted that quickly. I go in and clean up some of these ends, but as I mentioned on that kind of safety point earlier, nobody had to step foot in the road, nobody had to play Frogger, run around in the road, and aside from the safety point, as I'm driving down here in an air-conditioned vehicle, I'm just thinking about how long it would take to go topo in all of this, all of these linear feet of paint stripes. Cool. So that ends the video section. Basically, the last section is just any questions, concerns, things people want to see. I was usually going to show some of the software stuff. I'll usually open up the software at the end, but since we just did the slides here, I do have my email on there if anybody needs to screen grab that or send any questions over, or like I said, John's kind of representing us in the room. So after the meeting, anybody can hit him with questions too.
Thanks for that, Skyler. That was a quick run through. I really appreciate you speeding that up and walking through those videos. As we look at the chat, let's see. Just Rob made a comment. Running 64 gigs. It handles most data sets, less than 100 scans. Well, it just lags if you're working over a network. So it's best to process locally.
Yeah, that's a great point. So one thing I do, one of my responsibilities is performance testing for TBC, PC specs, like the recommended PC specs for mobile mapping. So just one comment or one addition to Rob's comment is that the speed of the drive where the raw data is one of the most critical components in the PCs. So like on my PC, what I call the working drive being fast is, if you have a good CPU and good memory and everything else is as fast as it can be and you're running off a network or running off an old hard drive, that's definitely going to be your bottleneck processing large point clouds. So the thing I always teach people is like, unless all your components are somewhat equally balanced, like in this case, the network is your bottleneck. If anything's kind of imbalanced, it doesn't matter how fast the rest of the PC is. So improving that working drive speed is always, it's most people's bottleneck. So that's always the first recommendation on PC changes.
There was another question about PCs and TBC working with scans, about the minimum RAM amount on a computer. Roberto asked that question.
Yeah, and I think that's what Rob was replying to, but minimum RAM, as far as like minimum practical, I would say is usually 32 gigabytes. But the thing that gets missed a lot is the speed of the RAM. I would take a very fast 6,000 megahertz kit of 64 gigabytes over a slow kit of 128 gigabytes. So that's another thing to kind of keep in consideration, is the amount of RAM isn't the only performance spec on a RAM kit.